Hello, everyone. Uh, we're just going to wait for a couple of more minutes, maybe, for the rest of the participants to join in. I would ask everyone that you mute your microphones during the presentation. Uh, yeah, we'll begin in just a few minutes. This presentation is going to be a little on the long side, so it might be a good idea to grab yourself a coffee or a sandwich and get comfortable. So I'll see you in a few minutes. Okay, hello again. We will begin our presentation in a few moments. First of all, I would like to kindly request that everyone mutes their microphones, just so that it doesn't interfere with the presentation. If you have any questions during the course of this webinar, please write those questions into the chat in Zoom. We have a team of specialists standing by, and they will be answering your questions as we go. If we, sometimes it happens during webinars that there are so many questions that we don't have time to answer all of them during the webinar itself. So in this case, somebody will still review the questions and provide answers to you later on. Now, one important announcement. Everyone here can request a certification, a certificate of attendance here of participation. So, and with this certificate, you can have a 5% discount on the machines that we will be presenting today. We're going to be talking about two actual machines towards the end of the presentation. So please stay tuned. And in the end, we will take you to our assembly facility, and we'll actually show you two actual live machines that we now have there. There will be an engineer who will present you the information on those machines, and I'll translate this information for you. That will be in the end of the presentation. All right, so I guess with that out of the way, I guess we can begin. So we wanted to talk today about bitumen emulsion technologies. Now, bitumen is among the most common organic binders. Its most valuable construction properties are water resistance, chemical resistance, and excuse me, just a second. Yeah, we can go to the next slide, please. Next slide. Thanks. So anyway, as I was saying, bitumen has some very important properties for construction, and it's water resistance, resistance to chemicals, its ability to soften when heated, and the way it sticks to wood, stone, metal, and plastic, and the way its viscosity grows very fast during cooling. When it cools down, it solidifies very quickly. So the most massive consumers of bitumen are construction industries. They're road construction, industrial, civil construction. And bitumen is often used as a waterproofing material when building things or in construction of various hydrostructures, laying pipes and other communications. And of course, a large amount of bitumen is also used in roofing. So bitumen and road construction, and this is the main focus, I guess, of our presentation today, is the primary binder that is used for the creation and repair of hard pavement. So depending on the nature of the application of bitumen, there are several types of bitumen. There are road bitumens, and they are the ones that are most produced. Construction bitumens and special bitumens that are used to make paints, varnishes, and battery mastics in the radio engineering industry. And there's the high melting bitumen that's also called Robrax. So road bitumen, in turn, can be liquid or viscous. Now, viscous bitumen is used for surface treatment of pavement. It's used for impregnation of crushed stone materials in production of asphalt, concrete, and bitumen mineral mixtures in various climatic zones. So liquid bitumen is used as a binding material in the construction of road surfaces and for many types of road works, and for preparation of bitumen mineral mixtures with cold laying, for surface treatment of gravel roads and crushed stone surfaces. And bitumen is a very old construction material. Its first use dates back to something like 3,800 before Common Era, and it was used as a construction material at that time already. And natural bitumen and asphalt, mined in the areas of oil fields, usually were used as binders, antiseptics, anti-corrosive, and waterproofing materials for the construction of buildings, towers, and whatnot. It was used to create water supply and to build drainage channels, tunnels, grain and water reservoirs, also in road construction and in shipbuilding. And bitumen was used to build crane storage, to fasten slabs of walls together in the floors and temples. And bitumen was used in medicine, and it was even used for mummification in places in cultures that practiced that. So the ability of bitumen to preserve and protect what it covers is due to its high resistance to water and air, and it's very airtight, basically. So with the development of the oil industry in the recent, I guess, hundreds of years or so, the processing of asphalt resinous oil increased, so the production of bitumen increased along with its quality. And such bitumen replaced natural tar asphalt. But still, the natural asphalt is also extracted to this day still. So currently, bitumen is widely used in construction, in various industries, in agriculture, and for radiation shielding of all things. That's interesting. So the leading field, however, of bitumen application is the construction and repair of roads, buildings, industrial facilities, and also airports. Next slide, please. So, okay, under normal conditions, if we are talking about a temperature of 20 to say 30 degrees centigrade, bitumen is a solid or highly viscous material that cannot be easily applied to things, right? It's solid. So in order to be able to use it, it must be converted into a liquid. And we can do this in one of the three ways. So first we can heat it, and in between 100 to 200 degrees Celsius, bitumen turns kind of liquid, and it becomes more convenient to be mixed with mineral materials. So something like preparing asphalt concrete mixtures, or for application in its straight form on road surfaces when we do priming layers and asphalt pavements. And asphalt concrete mixture prepared with hot bitumen, as a rule, are stored, transported, and applied hot, with the possible exception of cold stored bitumen mineral mixtures, which are prepared with heating but stored and applied cold. Another way we can have bitumen liquid is by diluting it or solving it with refined light oil products. So in this case, viscous bitumen is mixed with petroleum-based products such as kerosene or diesel fuel, gasoline, etc., and thus it becomes a liquid. And the third way to have our bitumen in a liquid form is to emulsify it with water, adding an emulsifier, a surfactant. And when we emulsify bitumen, we get the emulsion, which remains liquid even under normal ordinary temperatures of about 20, 30 degrees Celsius. So when we pave roads using hot asphalt concrete mixture that are prepared based on hot bitumen, such as, you get crushed stone mastic mixtures, hot compacted or cast mixtures, the road surface hardens and gains strength as the applied mixture cools down. And this method has both advantages and limitations. And the advantages include the possibility of having asphalt concrete with high strength when using high viscosity bitumen for roads with heavy traffic. But the limitations include such things as obviously high energy consumption for heating the materials and the production of mixes. Also, there is a limited seasonal period of time for the construction of structural layers of pavement. And also there is a pretty harmful impact on the environment during the entire production cycle as well. Now, asphalt pavements made, no, back one slide, we're not done yet. Thank you. So asphalt pavements made with liquefied bitumen, called organic mineral mixtures, gain strength not during the cooling process, but instead due to the evaporation of that light hydrocarbon fraction contained in the solvent. And this method, as a rule, is a lot more expensive due to the cost of the solvents. And the solvents must evaporate in a relatively short period of time, which of course is not very good to the environment. And since they are very volatile, it also increases the fire hazard during work. So there are also the third way, emulsification, and asphalt concrete and other road building mixtures prepared with emulsified bitumen, such as cast emulsion mineral mixtures, slurry seal, microsurfacing, cold asphalt, and asphalt granular concrete. These gain strength in the process of the emulsion breaking into its ingredients, into bitumen and water. And this breaking starts due to the interaction of the emulsifier surfactant with the mineral material. So this method, when we use bitumen emulsions, does not require heating, and it can be used with cold and even wet mineral materials, which makes it possible to reduce energy consumption by as much as 40 or even 50% when we compare it to the traditional hot technologies. So the best method for combining bitumen with an inorganic inorganic material, mineral material, is to use bitumen emulsions, we believe. Next slide now, please. So there are obviously benefits to this. And one is that the viscosity of bitumen emulsions at room temperature is several orders of magnitude lower than that of actual bitumen, straight bitumen. So low viscosity ensures easy permeation of bituminous material into even the smallest pores, and ensures its alignment even in thick layers of inorganic material. The second advantage is the higher adhesion to surfaces of various structures and of various nature, be that acidic or alkaline minerals or metals even. Increased adhesion contributes to the creation of strong and very durable road surfaces and road structures. The third advantage is the ability to operate in low temperatures and in high humidity by improving the adhesion forces of the binder to the surface of the stone. And in this case, the moisture content of the inorganic material of the minerals, it actually plays a positive role when it's combined with a bitumen emulsion. The fourth advantage is the reduction of viscosity, and that reduction improves the accuracy of portioning the substance, and it allows distribution of the material in thinner layers. And that also saves us some bitumen because it's applied a lot more sparingly and a lot more economically. The fifth advantage is that we save fuel or electricity when we make cold emulsion mineral mixtures, because we don't need heating of the stone materials involved. So the combination process takes place under normal conditions, and we don't require any energy intensive processes or equipment. Okay. And last but not least, of course, there is a reduction of harmful emissions into the atmosphere and the reduction of fire and explosion hazard. And at present, hot bitumen is increasingly being replaced by bitumen emulsions both in road construction and industrial construction. So the use of emulsion makes it possible to increase work productivity, the quality of coatings, and in addition, it becomes possible to use emulsions whenever it's impossible or inconvenient to use hot bitumen. Next slide. Next slide, please. Thank you. Okay, so what is this bitumen emulsion we speak of? So an emulsion is a dispersed colloidal system of two immiscible liquids of two phases, one of which is distributed in the form of small drops in the other. In the event that one of the phases is water and the second phase is a non-polar or low polarity liquid, and for the purpose of this webinar, we're going to call it oil. So bituminous emulsion or water bitumen emulsion is a dark brown liquid. It's made by dispersing bitumen in water. And this process is counteracted by the internal cohesion and viscosity of bitumen, as well as by the surface tension force, which resists the formation of a new interface. So when this mixing process is stopped, the emulsion quickly breaks and bitumen particles can merge, and this is called coalescence. Okay, so to keep the components mixed and to keep the emulsion stable, an emulsifier is introduced into the emulsion, and it is a surfactant that prevents or slows down the separation of these two phases. The emulsifier molecule is polar. Its tail is compatible with bitumen particles, attracted to bitumen particles. And the other side of the molecule, its head, is repelled by other emulsifier molecules. So that prevents bitumen particles from joining together, which ensures that suspended state of the bitumen particles and ensures the stability of our emulsion. And the emulsifier adsorbed on the surface of the bitumen droplets creates you may call it a barrier, like force field of electrical and spatial repulsion, which prevents them from joining. So the ability of the emulsion is ensured by electromechanical forces and interaction. Next slide, please. So, okay, ingredients. In addition to bitumen, water, and an emulsifier, the emulsion may contain a, excuse me, a stabilizer, acid or alkali, as the case may be. It can contain various solvents and thinners as well. So the acid is needed to improve the stability of the emulsion. And in most cases, we'd use like hydrochloric acid or orthophosphoric acid, maybe acetic acid. And in the case of anionic emulsions, however, we use alkalis, not acids. Okay. Stabilizers. Stabilizers are used to reduce the changes in the physical and chemical properties of the emulsion during storage and use. And that would likely be something like 0.05 to 0.1% of a 30 to 35% calcium chloride solution by weight. Solvents or thinners, that is a light oil fraction with a boiling point of 140 to 220 degrees centigrade. It's added in the amount of maybe 0.5% to 3%, and it's used to help create a homogeneous system. Thinners, such as vacuum gas oils, oil fractions, etc., are added in a wide range, anywhere from 5 to 30% by weight, to increase the penetration of bitumen to the required value and to give the emulsion a stable liquid state. To improve the adhesive properties of the finished emulsion, we can add an adhesive additive. So also when making bitumen emulsions, polymers and modifying additives can be added. And a modified bitumen emulsion is an emulsion made with obviously modified bitumen or containing modifying additives such as latex, polyethylene, epoxy resin, or synthetic rubber, synthetic resin, etc. The list goes on. So modification of bitumen emulsion can be done in two ways. We can introduce a modifying agent into the water phase of the emulsion, or we can directly inject it into the emulsion during its preparation. And the second way is by building or making emulsion based on modified bitumen. Next slide, please. All right, so let's classify bitumen emulsions. So based on the nature of the liquid in the emulsion phases, there are several criteria. Okay, so depending on the nature of the liquid in the composition of the emulsion phases, we have direct emulsions or oil and water emulsions. And this is when bitumen droplets, the dispersed phase, are dispersed in water, which is called dispersion medium. And they're dispersed in the form of tiny droplets from 1 to 10 microns in size, and they're surrounded by, like I mentioned, a layer of an emulsifier. The opposite type is indirect type, I guess, is water in oil emulsions, when water is the dispersed phase and is dispersed in bitumen, which is the dispersion medium in this case. And water droplets in this type of emulsion are also stabilized by a layer of emulsifier. It should be noted that during the production process, both types of emulsions can form simultaneously, especially if using double-purpose emulsifiers. And such emulsions are also called combined sometimes. So what type of emulsion will eventually turn out will depend on the nature of the bitumen, the pH of the water phase, and the ratio of the volume of the phases. So in order for the emulsifier to function as a surfactant at the oil-water interface, so for it to be adsorbed, it must have an affinity of the same order for both phases. If this condition is not met, the emulsifier will move from the interface to the phase for which its affinity is greater. And typical examples of such well-balanced substances are some soaps, the molecules of which have an organic tail with a strong affinity for oil, and an ionized head with a significant affinity for water. So with very short tails, the affinity for water predominates and the molecules absorbed into the water. That means the emulsifier is poorly balanced. However, with very long tails, the affinity for oil dominates and the emulsifier, again, is poorly balanced. So with a certain average ratio of the length of the head and tail chains, an optimal balance and therefore the best stabilizing effect can be achieved. And for the purpose of clarity, we can depict the behavior of emulsifier molecules differently balanced in their polarity as this. In the first column here, we see molecules with the predominantly polar part, and in the second, a predominantly non-polar part. And in the third column, the polar and non-polar parts of the same strength. So the emulsifier is highly hydrophilic or very oleophilic. Practically soluble in one of the phases forming the emulsion, then at any ratios of phase volumes, the emulsion will only be of one type. So we can summarize that direct emulsions are formed when surfactant molecules with the highly hydrated polar group and the moderately developed hydrophobic part are introduced into this system. Inverse emulsions are stabilized by surfactant molecules with a weakly hydrated polar group and a highly developed hydrocarbon part, preferably containing 2 to 3 hydrocarbon chains, as in the case of multivalent metal soaps. And this role of the ratios of the actual geometric dimensions of the polar group and hydrocarbon part of the molecules of surfactants in the ability to stabilize emulsions of one type or another is quite obvious and indisputable. And at the same time, it's clear that such a geometric scheme is quite simplified, but it will work for us. So in some emulsifiers, it's possible to obtain both direct and inverted emulsions with the same phase ratio and without changing the pH of the medium. It's only necessary to change the volume of emulsifier in the system. So with small amounts of emulsifier, we get a inverse water and oil emulsion. And as we increase the concentration of the emulsifier, we reach a certain limit. And when we step over that limit, we get oil in water emulsion. And with a further increase in the concentration of the emulsifier, the dispersion of the emulsion increases, reaching its limit at a certain ratio again, after which an inverse emulsion forms again. Next slide, please. All right, so let's look at the classification of bitumen emulsions depending on the concentration of the dispersed phase. And bitumen emulsions can be subdivided into low concentration, up to 40% bitumen, concentrated emulsions with up to 74% bitumen, and highly concentrated emulsions, which contain more than 74% bitumen. So currently, only the first two types are mostly used in road construction. Highly concentrated emulsions are extremely rare and currently practically not produced at all. However, they are quite promising in many production processes where it's necessary to transport emulsions over long distances. Okay, next slide, please. Also, we can classify emulsions depending on the nature of the emulsifier. Okay, so direct type emulsions are usually divided into the following classes. There are anionic emulsions, where an anionic surfactant is used. There are cationic emulsions with the cationic surfactant. There are amphoteric emulsions with the double-purpose emulsifiers, and these are compounds that ionize and act differently in water solutions depending on the pH. And they exhibit the properties of cationic surfactants in an acidic solution, and they become anionic surfactants in an alkaline solution. And then there are non-ionic. Those have surface active properties, not dissociating into ions in water solutions. And there are emulsions based on solid emulsifiers. Now, emulsions of the inverse type, depending on the nature of the emulsifier, were usually not separated into classes. But now, when it became possible to choose from a wide range of various emulsifiers, we can also divide them into surfactant emulsions and solid emulsifier emulsions, and emulsions based on non-ionic emulsifiers. And this type of inverse emulsions kind of still under development, but it has prospects, especially in the case of using an emulsifier that is sensitive to temperature change during the preparation or application of the emulsion. So there are some promising applications there. Okay, next slide, please. All right, so in road construction practice, the most commonly used emulsions are direct type oil and water. So primarily anionic or cationic. And therefore, the classification of these emulsions, for example, in the United States is based on such an important characteristics of their properties as the rate of mixture formation based on these emulsions, or the rate of breaking of the emulsions. So basically how soon the bitumen released from the emulsion when it breaks achieves its original properties and forms a continuous film. So we can have rapid setting, RS, medium setting, MS, a slow setting, SS, and superstable emulsions, QS. And for convenience of classification, a special international system of symbols for the designation of an emulsion has been developed, and it makes it easier for users to choose the required type and grade of bitumen emulsion. And we're talking about standards such as the ISTM D977, D2397, there is AA SHTO M140, and M208. So first of all, the type of emulsion is indicated by the rate of its breaking setting. For example, a rapidly setting emulsion will be designated RS. Then either letter C is put in front of the type of the emulsion, which would mean a cationic emulsion, or no letter is put before the designation, and that means that it's anionic. So RS would mean a fast anionic emulsion, CRS would mean a fast cationic emulsion. And the next parameter is the viscosity of the resulting emulsion. It's indicated on a relative scale. It's either 1 or 2. The number 1 indicates that the emulsion is more viscous than the emulsion with the index 2. So for some brands of emulsions, we also use letters H or S in the designation, indicating solid or hard for H, or soft for S bitumen. So for some types of anionic emulsions, we can have letters HF in front, which means the addition of special agents to the emulsion, which gives it the property of high flotation. So the emulsion creates a thick bitumen film on the mineral material. Okay. So for example, if we have an emulsion that is designated something like HFMS-2H, is an anionic medium setting emulsion based on hard bitumen with a low viscosity and the addition of special flotation agents. And if we have an emulsion that's designated as CSS1S, that means it's a cationic slow setting emulsion with high viscosity, and it's based on soft bitumen. So basically a bitumen with a dilutant thinner. Now, superstable emulsions include emulsions based on solid emulsifiers, also known as pastes. Okay, so the expansion of the use of polymer modified bitumen was also reflected in these designations, and we do that by adding letter P at the end of the designation, I guess, for polymer. So, for example, if we have an emulsion called HFRS2SP, that stands for anionic, rapid setting, high flotation emulsion of low viscosity, based on thin polymer modified bitumen. Okay, and every country has their own standards, of course. For example, in Finland, the standard does not include classification of emulsions at all, but what they do in Finland is they impose requirements on an emulsion that is designed for specific roadworks. For example, you'd have something like BE-SIP, and that would mean it's an emulsion specifically designed for surface treatments. Okay. All right, next slide. So the purpose of the bitumen emulsion basically is determined by its properties. So it easily applies to various surfaces, including vertical surfaces. And due to its low viscosity, it penetrates into the pores of materials. It also mixes very well with mineral materials, such as crushed stone or gravel, sand, or mineral powders of various kinds, firmly binding them together. And it can be said that bitumen emulsions perform two main functions. So the binding function is the use of an emulsion to bind mineral materials and their particles together, which is a prerequisite for the production of asphalt mixtures. There is the protective function, and it serves to protect materials and surfaces from the effects of aggressive materials or media, such as water or salt, maybe. So in road construction, bitumen emulsions are used for the construction of crushed stone surfaces and the construction of gravel roads as well by impregnation method, by pre-mixing, and by mixing on the road itself. So for the construction of asphalt, concrete pavements, and also for treatment of dirt roads if necessary. Excuse me. So bitumen emulsions can also be used for a wide range of road construction works, right? It can be surface treatment. Now, cold emulsion mineral mixtures produced both in the mixer and the factory, and by mixing it straight on the road. It's used for cold storage mixes, tack layers, pothole patch repairs, things like that, and creation of thin film protection layers. And in addition to road construction, bitumen emulsions are used in a number of other areas. In construction, bitumen emulsions are used to protect concrete, to protect foundations, walls, floors. It's used for impregnating the soil, which makes it waterproof, and also for coating metal parts to protect them against corrosion. And in industrial processes, emulsions of bitumen and water can be used in the manufacture of electrical and thermal insulation materials. In the paper industry, bitumen emulsions are used to make waterproof cardboard. In agriculture, emulsions are used to control and manage the temperature and humidity of soils, and also to strengthen and reinforce loose ends, keep them in place. Okay, and such widespread use of bitumen emulsions is due to the presence of bitumen in them in the form that allows it to be used in a cold state without the need to heat. So, which has a number of advantages over the use of hot bitumen, as we've discussed a few minutes before. Okay, next slide, please. All right, so extensive experience shows that the most effective use of bitumen emulsions is in the so-called cold technologies for the construction and repair of roads. So first, we'll talk about priming coats. Priming is the application of an emulsion by spraying it on the surface in the form of a thin layer, which ensures reliable adhesion of the asphalt concrete mixtures to the underlying layer. And for most types of pavement, such as concrete or various basic pavement layers, bottom pavement layers, the creation of the binding layer is not only desirable, but it's also necessary. And one of the types of priming is the application of the so-called initial coating, when a slow emulsion with a bitumen content of 55 to 60% is sprayed onto a granular base to prepare it for the application of an asphalt concrete mix. And depending on the properties of the base, the specific amount of the emulsion applied would be maybe 0.4 to 1.4 liters per square meter. Next slide, please. Next thing is the surface treatment, and surface pavement treatment is performed on new asphalt concrete, on various types of black and cement concrete pavements, as well as on used pavements to ensure the necessary traction of vehicle wheels to the pavement surface, and also to increase the service life of the pavement by protecting it against the elements. So the layer created by surface treatment serves to give the coating certain roughness, water resistance, wear resistance, and certain density. And we're talking here about both an inexpensive one-time single treatment of secondary road surfaces, and also the creation of wear-resistant surface layers on roads with relatively high traffic density. And it's important to note that the strength of the base to which the surface treatment is applied is also necessary to take into consideration. Okay, next slide, please. Right. So crushed stone impregnation is another use. Construction of structural layers, bases, and coatings by multiple scattering of crushed stone of various fractions, compaction of such stone, and also impregnation with bitumen, usually twice, with a slow breaking emulsion that contains 50 to 65% bitumen. And there is the patch repairs. The use of bitumen emulsions greatly simplifies the repair process. It allows work to start in early spring and to end somewhere in late autumn, well, especially specifically in moderate climates like what we have and where we are. So it can be used in an air temperature of as low as 5 degrees Celsius. So when using emulsions, it becomes possible to use it on wet materials because in this case, cationic bitumen emulsions ensure fast formation of binder film. They show high adhesion of the film to the surface of most aggregates, and in general, we get a good quality of these repair works. And the emulsion consumption in this case would be 1.3 to 1.6 liters per square meter for each centimeter of the depth that was cut from the original surface. Okay. All right, next. In addition, emulsions are widely used in other technology processes that include slurry seal, microsurfacing, multimac, and cold recycling. So slurry seal is a method of applying thin layers over existing pavement. And this cold mixture consists of a dense mineral material with a filler, usually Portland cement, and it's mixed to a uniform consistency with a bitumen emulsion and water. And after the so-called drying time, the surface becomes impermeable to water. The coefficient of the traction is improved. So the old coat is protected from water, oxidation, and protected from further breaking and deterioration. And the thickness of the slurry seal coat is from 1 to 1.5 times the size of stone grain. So that would be something like up to 8 millimeters. And this mixture uses a material homogeneous in terms of particle size distribution. So when increasing thickness to improve mechanical properties and its shear stability, latex modifiers are applied. And the mixture has a high surface tension and is self-leveling. So with the help of slurry seal, what can be done is a slight rutting and any longitudinal deformations of the profile can be compensated and repaired. Since there are practically no voids in the hardened mass, it resists compression really well under traffic. So after the coating is done, traffic can be resumed after about 1 to 4 hours. Microsurfacing emerged as a further development of the slurry seal technology, and with its help, a sufficiently thick and durable coating is created. Microsurfacing can be applied in 2 layers of 25 to 30 millimeters. In some cases, the total thickness reaches 75 millimeters. So with microsurface technology, a larger stone material is used. It's and the bond is actually stronger than slurry seal, so the coating can withstand fairly heavy loads without deformation. And for better shear stability, again, latex is introduced into the mix. Okay, next slide, please. Now, microsurfacing, that is used to eliminate rutting and to fix minor profile defects and to expand road shoulders. And basically, in any case, when slurry seal can be used, microsurface is used as well. So microsurfacing emulsions are, you could call them some like fast traffic emulsions. So they set in just 30 to 60 minutes. And if the coat is created in 2 passes, and the first layer closes the cracks and smooths out the surface. And the second coat is recommended to be applied no earlier than 1 day later. So when the repair is completed, traffic can be resumed in about 30 minutes. However, for 1 hour, the traffic speed, the driving speed should be limited to about 40 kilometers per hour. So both slurry seal and microsurfacing seals imply a fairly quick application at a speed of 3 to 6 kilometers per hour. And both technologies allow to quickly restore the road surface. Both act as a protective layer to prevent wear on the top of the road. And they can withstand fairly heavy loads and traffic intensities. And their average service life would be something like 3 years. Okay. Next slide, please. Okay, next is Multimac. It's a thin layer coating that has the function of a protective layer or wear layers. It cements the damaged base, fills all the cracks and voids with the bitumen mineral mixture, and it evens out deformed pavement. So the mixture is prepared and distributed by a special stacking machine that is equipped with the computerized dosage system for the components, for the ingredients. Multimac does not require any special sealing, and traffic is possible within 20 or 40 minutes after work completion. And last but not least, recycling is a technology of strengthening of soils, stone materials, and asphalt granulates obtained as a result of crushing asphalt concrete scrap, various binders by cutting and mixing it directly on the road, as you can see in the picture on the right. Now we can go to the next slide. Right, so some of the other emulsion applications, crack sealing in the road pavement, that can also be done with emulsions. Cracks are filled with an emulsion mixed with fine-grained sand, leaving a few millimeters to the surface. And after settling, after solidification, the remaining volume is filled with straight emulsion without sand. And sand is then applied to the surface to protect that patch material from being carried away by traffic wheels, etc. So bituminous emulsion can also be used to reinforce slopes, sands, to prevent dust formation on unreinforced materials. And in many cases, emulsions can be used as waterproofing materials. Okay. Now, emulsions are good, right? So how do we make them? And next slide will tell us how. Next slide, please. Right. So bituminous emulsions are usually made using a colloid mill, but they can also be prepared using other dispersing devices. In a colloid mill, an emulsion is produced by passing a mixture of hot bitumen and a water phase between a rotating rotor, basically a disc or cone, and a non-rotating stator. So the rotor, just like the stator, can have slots or teeth to create a turbulent flow of the material. And for the preparation of bitumen emulsion, we can have batch or continuous production plants. The batch production process consists of at least two stages. So the first stage would be the preparation of the so-called water phase, or soap phase, it's sometimes called. And the actual production of the emulsion is the second stage. So a water phase is prepared in a tank into which we supply heated water, emulsifier, acid or alkali, and any other additives that are necessary to the product formula, okay? And the resulting solution is then mixed. And at the stage of emulsion production, bitumen and the previously prepared water phase are fed in a certain proportion, and they're fed to a colloid mill. If the addition of a solvent to bitumen is required, then a bitumen portioning tank is also needed, or the solvent may be injected and dosed directly into the bitumen stream continuously. So in a batch unit, only a few material streams are involved in the actual production process, which allows manual control. The exact dosage of the various ingredients plays a decisive role in ensuring the quality of the emulsion. The use of fully automated, or at least somewhat automated controls, provides a more efficient production process with a decrease in possible operator errors. The chemical additives that we use in this process can be hazardous to health or corrosive to metal. And this means that it's possible, or preferable rather, to use a closed dosing system, which is better than using open tanks and portable pumps. That would be much better for safety of the personnel, and it will also help comply with the environmental protection rules. Okay. Next slide, please. We need to go to the, thank you. So in a continuous production process, water heating and dosing of all materials are performed continuously using separate portioning pumps for each of the materials, and batch tanks are not used. Instead, the water phase supply systems designed to provide a sufficient time interval for the reaction between the chemical additives to neutralize and dissolve until the water phase combines with bitumen. And this process requires the use of automated controls with flow meters for the dosage of all materials, with the exception of acid, the supply of which is actually controlled based on the measured pH of the water phase. So when making an emulsion, it's possible to use various polymer modifiers such as latexes, SBS, or other additives to bitumen. In this case, it becomes necessary to equip the plant with additional assemblies, as well as to implement appropriate technical solutions. Latex, for example, is sensitive to external factors that can cause it to break down, clogging pumps or pipelines even. In the case of SBS polymers, it's usually necessary to output the emulsion at a temperature above the boiling point of water, which in turn requires overpressure, and then cooling of the product before it's fed into the storage tank with a transition to normal atmospheric pressure. All right, so next slide. And today we'll show you two batch process machines made by Globecore with a capacity of 2 cubic meter per hour and 8 cubic meter per hour of emulsion production. Next slide, please. Here you can see the specifications of these plants. Okay, next, please. Thank you. So yeah, you can see that one has a production capacity of 2 to 3 and the other of 8 cubic meters per hour. And that is including the preparation time for the production of the water phase. I'm looking at the table right now thinking maybe I should point out some other properties to you, but I guess okay. You can see that we can add emulsifiers, adhesive, latex, and basically any other additive that the process formula may require. So in this respect, the machines are quite flexible. You may also note how small they are. Basically just about, the smaller machine is just about 2 meters in length. So that makes it quite easy to install in place. All right, next slide. Right. So both of these plants are semi-automatic. It means that they have automation, but not the whole process is automated. So some operator involvement is still required. And they consist of several independent sections that are connected by pipelines, but are mounted on the same frame. So the plants can be divided into sub-units: an emulsion preparation unit, a water phase preparation unit, and also the control panel, a control device. Okay, next slide. Okay, the emulsion preparation unit is basically a three-stage mixer with a pipeline system with valves, a bitumen pump, and of course a rotary mill. And the components are equipped with heating jackets that are connected to a heating agent system. And this heating system ensures that the heating agent passes through the system and maintains the process temperature that, as you know, is required for bitumen emulsification process. So the water preparation unit consists of a blend intake tank that is connected to the piping systems that has indicators for visual control of the liquid. There are control valves, instrumentation, shut-off valves, and all of that stuff is mounted on the same frame as the emulsion preparation unit. And you will see a lot more of this when we show you the actual machine in our production facility. But this unit is equipped with temperature and pressure sensors as well. So there are several temperature measurement points. We do that at water supply, at blend supply, at bitumen supply to the blend, and at the point of feeding bitumen into the mixer, and of course at the product output. And we also measure pressure, and the points are at the inlet of the machine, after the bitumen pump, and just before the colloid mill. Okay, next slide, please. And in this slide here, you can see on the left is the control panel, and it contains a Mitsubishi PLC controller and multifunctional Autonics meters. And these meters can also send control signals, so they're regulator meters, I guess, or small controllers. It contains protective and starting equipment. And on the front panel of the controller is a mode switch, control buttons, and various process indicators, and the mimic diagram or process diagram of the plant. And the plant can operate in two modes. We can operate it in manually, and this is done usually to check and adjust the individual components of the plant or to adjust the process formula. And there is the automatic production of water bitumen emulsion. And the mode is chosen by pressing the mode button on the control panel. The controller, the PLC controller, manages the operational unit in all automatic mode. In case of an automatic stop or shutdown, if the monitored parameters go beyond the operating limits, an alarm message is displayed on the front panel of the controller, and the message remains on the front panel until, and the plant remains stopped and cannot be restarted until the operator confirms that the message has been received. And the controller also manages the parameters of the water bitumen emulsion production process. So signals are received from the meters that work in tandem with the pressure and temperature sensors, as I mentioned above. And the current values of these parameters of the process are displayed on digital indicators of the corresponding meters. And on the right, you can see that the unit is supplied with an emulsifier tank heater, which is connected to the existing oil heating system and is equipped with a bypass line with a three-way isolation valve, which allows us to disconnect it if necessary at any time. So basically a container with an emulsifier, like a barrel, would be put on top of this heater, and if need be, we can heat it to the necessary temperatures. Next slide, please. Okay, optional stuff. Okay, this is a latex injector. Our plants can be optionally equipped with this, and we can do this to make modified emulsions. In addition, the design of the plants allows the production of emulsions using modified bitumen while providing emulsion cooling by heat exchangers at the outlet of the unit for further supply to the finished product containers. And the plants also allow producing of all types of emulsion. You can do cationic, fast, medium, and slow setting emulsions, anionic emulsions, the same types of all types, actually, including the H, subtype H, so the emulsions that are based on hard bitumen. And all emulsions that are produced with globe core plants, if they're done right, they comply entirely with the ASTM D239798 and D97798 standards for cationic and anionic emulsions, respectively. Next slide, please. All right. So the principle of operation of globe core bitumen emulsion plants is based on sequential mixing of components in hydrodynamic mixers at a certain pressure and temperature. Right. So due to its unique design, the hydrodynamic mixer provides instant mixing of the components in the stream due to the sheer kinetic energy of the bitumen stream, more like a jet. It goes in at high speed, and that allows us to make the mixer rather small. So this principle is used for mixing the components of the water phase, of bitumen and solvent, as well as the bitumen phase and the water phase in the end. Okay. So the main part of the machine is this. Okay, this is where the main mixing is done, and the mill serves the purpose of homogenizing the product later on, and we'll get to that in just a second. Next slide, please. So here is the water phase production, and when we circulate water in the tank, this pump draws in the necessary components through the mixer. The components are supplied one by one sequentially by opening the valves of the measuring containers to obtain a water solution of the emulsifier. And this way, in our plant, we make a concentrated emulsifier solution, which instantly forms an aqueous phase with specified characteristics, and mixing in the required proportions with water heated to the process temperature. And this water phase is prepared immediately before mixing with the bitumen phase, and it flows from its mixer to the mixer for the bitumen emulsion. And the advantages of this method is precise proportion adjustment, a significant reduction in mixing time, and the elimination of big mixing tanks for homogenizing the product. So therefore, we can get a fairly small-sized plant all in all. The supply of each component is constantly adjusted during mixing to ensure the output of the finished product with the required parameters as per the necessary product formula. Another obvious advantage of this technology lies in the fact that the plants can work longer from one batch of water without the need to use large containers for blending, since the concentrate of the water phase is increased in volume by as much as 5 times before entering the emulsion mixer. In addition, the mixer allows to take some load off the mill, which serves mainly to stabilize the already mixed emulsion. And this is reflected both in the quality of the emulsion obtained and in the service life of the mill, which is extended quite noticeably. As a result, we get a homogenized product at the entrance to the mill, mixed at the molecular level, and it's pretty much already a homogeneous liquid. And the final homogenization and stabilization of the emulsion place takes part in the mill, where we get the final product of the highest quality with the required parameters. So let's talk something about the mills. Next slide, please. Okay, so this is a globe core colloid mill, and these mills are driven by belt drives, which allows the necessary peripheral speeds with a relatively small size. And the tool itself is made of corrosion-resistant steels, which maximizes its wear resistance and service life. And the design of the stator rotor system relief its nozzle type, and it allows for the maximum number of very small streams of liquid, which we then disperse into droplets for the process and the subsequent stabilization of the product. Next slide, please. All right, and here's how it works. This is a process diagram for the production of bitumen emulsions. Now, we have certain equipment requirements here. So in addition to the plant that is shown in position 10, the equipment should include 1 bitumen boiler, 2 a bitumen pump, 3 a heating station for the heating agent with a circulation pump, 4 a water tank, 5 a thinner tank, 6 an emulsion reservoir, 7 an acid tank, or an alkali tank, as the case may be, 8 an emulsion pump, and 9 a compressor, an air compressor. The next slide, please. All right, so let's look at how it works. So before starting, all bitumen pumps, pipelines in the plant are warmed up, heated to at least 110 degrees Celsius with the oil from the heating system that is provided by the heating station. Now, in the boiler, bitumen temperature is raised to 140 to 160 Celsius. Then in the water tank, water is heated to 40, 60 degrees Celsius and is supplied to the plant through the inlet valve V6 and the inlet filter. The water pump M3 then is turned on, and through the flow meter R2, the control valve, and the valve V7, water is circulated to stabilize the temperature in the water heating tank. Then the V8 valve opens, and about 800 to 900 liters of water is drawn into the tank in position 1. And that also depends on the product formula, the amount of water. Then acid is added to the supply tank in position 2 from an external container, usually by gravity feed through the valve V14. Then the emulsifier is supplied from an external barrel using a hand pump through the V15 valve into the tank is position 3. And if necessary, as I mentioned, this emulsifier can be heated before the process. The adhesive additive is pumped from also an external barrel, also by hand pump. It comes through the V16 valve into the tank position position 4, sorry. The blend pump M4 is turned on. The valve V4 here is in the position of blend mixing, and water circulates through the C5 injection mixer, and that's the hydrodynamic mixer. Vacuum is created in the injection chamber of the C5 mixer and it draws in all the ingredients. So by opening valves V17, 18, and 19, the operator, according to the product formula, dissolves all of these ingredients in water. And after 30 minutes of M4 pump operation, this blend in the tank is ready. And at this time, hot bitumen from the bitumen boiler goes into the plant through the inlet filter and through valve V27, and bitumen circulates through the small loop and goes back to the boiler. There is some circulation first. Then when the temperature at point T1 reaches 140 Celsius, the bitumen pump M1 is turned on, the V27 valve closes to a pressure of 0.5 to 1 bar, and bitumen starts circulating along a big loop and goes back to the boiler again. When the temperature at point T2 reaches 140 degrees Celsius, the operator selects auto operation mode, selects the mode with or without using a thinner, or with or without using latex, and then just presses the start button. And this automatic cycle starts by switching on the M2 mill. In this case, with a time delay, the following mechanisms are switched on in sequence. Water pump M3 starts, and blend pump M4, pneumatically driven valves V4 and V2 switch. If the process involves operation with a thinner, the M5 pump and the V3 valves are engaged. The V1 three-way bitumen valve turns to the necessary position, and the latex pump M6 starts and V30 valve opens. That is if we operate with latex. Okay. So after switching the bitumen valve for V1, the bitumen enters the mixer nozzle at a pressure of 14 bar. And in the C1 mixer, the thinner and bitumen are premixed. The flow rate of the thinner is controlled by a flow meter R1, and it's adjusted with a control valve. Now, in the C2 mixer, bitumen and water phase are mixed, and water phase is premixed with the blend in the C6 mixer. The percentage of water and blend is controlled by flow meters R2, R3, and it can be adjusted with the appropriate control valves. And then in the C3 mixer, finally, the bitumen and water phases are mixed at a higher level. And at the outlet of the mixer, we can inject latex into the mix by the M6 pump through the V30 valve if necessary. And then when the emulsion is done here, it passes through the M2 mill for final stabilization and homogenation. And last, the finished emulsion is collected and stored in a tank at a temperature of 40 to 60 degrees Celsius, right? And next slide now. So yeah, that's a nice little plant, and it's been operated in quite a few countries and quite a few places around the world. And these are some of the pictures. of plants that are successfully run in Europe, in Asia, in Africa, in South America. So quite a few of them out there. Okay, and why this is so successful. Okay, next slide, please. Because it's got advantages, right? So some of these are, the plants can produce practically any types of emulsion. It can be cationic emulsion with different setting rates, and anionic emulsions, modified emulsions. The plants ensure pretty high quality and stable quality rather, of the resulting product. There is ease of maintenance because there is a minimal amount of mechanical mixing devices, i.e. mills, and these are replaced mostly by hydrodynamic mixers with no rotating parts or drives. The equipment is rather small, as you've seen. There's a small footprint. It allows for a lot of flexibility in the production formula and a high precision of ingredient dosage. It can operate for a long time off one water phase batch because we dilute that concentrate immediately before emulsification. And of course, there is the Globcore quality that's been proven over decades. And the client can select a required production rate plant with ease. There is a wide product range. Okay, so that's about it. This concludes the presentation. Next slide. Next slide. And I hope that the information provided during this webinar was useful to you in any way. If you still have any questions, you can keep asking them to our team here in the text messages, or basically feel free to send us a letter. We'll be happy to address any of your concerns. So thank you for your attention, but do not leave yet. Stay tuned. We have something to show you right now. And let me just make sure that we have everything ready for the demonstration of the actual machines here. Just a second. Okay, please wait. Подождите, пожалуйста, мне еще надо небольшую подготовку. Секунду. Так, я не слышу цех.
Добрый день. Меня слышно?
Так, секунду, сейчас почти. Сейчас я добавлю громкости тебе. Попробуй еще раз что-то сказать.
Да, меня слышно. Добрый день.
Да, сейчас слышно, отлично. All right, everyone. This is our engineer. He is here to demonstrate for you the actual machines that we've talked about during the webinar. So I guess let's go.
Меня зовут Станислав, и сегодня я хочу вам представить две машины продукции компании Globcore. Это для производства битумной эмульсии однокубовая машина, и там дальше у нас для производства битумной эмульсии объемом 8 кубических метров в час.
Okay, so this is Stanislav, and he's here to demonstrate for you two of the Globcore machines. One is for bitumen emulsion production. One is a 1 cubic meter per hour machine, smaller one. And to the right, you'll eventually see the larger machine for 8 cubic meters of emulsion production. Okay.
Как мы знаем, для производства битумных эмульсий используются такие машины, которые порционного типа действия. И одна из таких машин, мы начнем с этой, это для производства битумной эмульсии объемом 1 кубический метр в час.
So these are batch process machines, and we will begin by showing you the machine for 1 cubic meter of emulsion production. Okay.
Суть работы этой машины составляет то, что два процесса происходят. Сначала мы готовим водную фазу, и потом смешивание водной фазы непосредственно с битумом.
Okay, and as I mentioned during the webinar, this machine works in two stages. The first stage is the creation of production, rather, of water phase, and the second stage is the production of bitumen emulsion proper.
Вначале я хочу показать битумную часть установки здесь, с этой стороны.
First of all, let's show you the bitumen section of the machine on this side of the machine.
Начнем с входа битума.
This is the input for bitumen.
Он Вот линия входа битума,
This is the bitumen input line,
подающий насос.
the bitumen supply pump here.
Дальше идет битум, и он доходит до гидродинамического смесителя.
And bitumen comes here into a hydrodynamic mixer.
В эту часть, в гидродинамический смеситель, параллельно подается водная фаза.
And water phase is supplied into this hydrodynamic mixer along this line at the same time.
После смешения в гидродинамическом смесителе продукт выходит в этой линии и идет на гомогенизацию.
And after this mixing, the product flows along this line for homogenation into the colloid mill.
Фактически эта компактная система обеспечивает основную работу установки.
And this compact and small size system actually facilitates most of the process of the production process.
Как мы знаем, для производства битумных эмульсий предусмотрено введение дополнительных компонентов. В данном случае я говорю о разжижителе.
As we know, bitumen emulsion production involves addition of various other components. In this case, this will be the thinner.
И разжижитель в этой системе подается непосредственно в битум.
And in this system, thinner is fed directly into the bitumen stream.
Если мы проследуем по этой линии разжижителя, мы увидим здесь.
If we follow this line for the thinner here, this is what we'll see.
Шестеренный насос для подачи разжижителя.
There is a gear pump to supply that thinner.
Также кран.
A valve.
И ротаметр.
And a flow meter.
Мы можем посредством регулировки крана и посредством наблюдения за показателями расходомера регулировать рецептуру.
And we basically adjust the supply using this regulation valve and looking at the needle on the flow meter.
Дальше я хочу вам показать систему водной фазы. Она предоставлена фактически здесь.
The next thing is the water phase system. This is where it is here.
Hello.
Подожди секундочку, Станислав.
Hello.
Yes, hello. Please, if you have any questions, can you please direct them into the text?
This is Hemanta Datta from India. From India, Bitchem, Guwahati, Assam.
Please, hello. Please, can you direct your questions into the text?
Are you listening me?
Can you please direct your questions to the text chat window in Zoom and mute your microphone?
Yes, Mr. Anton, you have shown your 1-ton bitumen emulsion plan. It is okay? Mr. Anton?
Yes, I cannot really hear you really well. Could you please write your question in the text window, in the chat? Somebody will answer your question from the chat window. Thank you. Станислав, я думаю, можем продолжать.
Сейчас, секундочку.
Только видео нету.
Да.
Поехали.
Что я хотел сказать о линии водной фазы. Вся работа функциональная обеспечивается одним насосом.
All right, so regarding this water phase section, all of this operation is facilitated by one pump.
Этот насос фактически делает три функции.
This pump here serves three functions.
Это подача воды и циркуляция воды во внешней емкости.
So first it supplies and circulates water in the external tank.
Смешивание и подача воды в купажную емкость, которая идет в комплекте установки.
It mixes that and supplies it into the blend tank, the large white tank that you can see here included in the machine.
И, соответственно, подача уже готового купажа, готовой водной фазы в систему смешивания с битумом.
And it also supplies the ready water phase into the system, which mixes it with bitumen.
Дальше я вам Хочу показать, что все компоненты, которые предоставлены, которые будут вводиться в воду, они смешиваются в гидродинамическом смесителе, который расположен у нас здесь, наверху.
Next here, we can see that the ingredients here are mixed in the hydrodynamic mixer installed here on the above this tank on the far side of the machine there.
Касательно компонентов, мы здесь имеем 3 емкости, в которых может быть кислота или щелочь, стабилизатор и эмульгатор.
And regarding the ingredients, we have these 3 smaller tanks, one on the left for acid, the other for the stabilizer, and the third one for the emulsifier.
Подача этих компонентов в гидродинамический смеситель осуществляется посредством простого включения поворота крана ручного.
They're supplied into the mixer quite easily by just turning these manual valves here.
Компоненты подтягиваются в зону разрежения в гидродинамический смеситель, где, соответственно, смешивается с водой.
And the components are drawn in or sucked in by vacuum in the hydrodynamic mixer. And in that mixer, they are, mixed with water. Okay. Next.
Когда компоненты, точнее водная фаза готова к подаче в битумную систему, то есть весь купаж смешался, простым включением крана мы подаем водную фазу в битумную линию.
So when we're done with mixing the blend, there's this valve here down below, and we turn that valve to supply the blend into the bitumen mixer for mixing with bitumen.
И дальше, как уже было сказано, водная линия вместе с битумом смешивается в гидродинамическом смесителе.
And then, yeah, this is where the water phase and bitumen are mixed in the bitumen emulsion mixer.
Соответственно, после гидродинамического смесителя продукт подается в коллоидную мельницу, и на выходе мы имеем готовый продукт.
So after the hydrodynamic mixer, the product goes into the colloid mill for homogenation, and after the colloid mill, it goes into the product output line.
Сейчас я хочу вам предоставить к показу другую установку. Это больше производительности, до 8 кубических метров в час.
This here is a larger machine with 8 cubic meters an hour capacity that I would like to show you.
Хочу уточнить, что эту машину мы взяли из цеха до сборки, то есть некоторые компоненты дополнительные могут отсутствовать, чтобы, основные узлы, которые для показа, мы сможем предоставить.
So yeah, this machine is in the very late stages of production for a client. So some components, some minor components might be missing from it, but the main components are all there. So it's good for our demonstration purposes.
В этой машине ровно так же, как и в предыдущей установке, имеются те же самые механизмы.
The basic makeup of the machine, the basic components are the same as the smaller machine.
Это насос подачи битума,
This is the bitumen supply pump here,
гидродинамический смеситель,
the hydrodynamic mixer here.
который после смешивания водная фаза подается здесь.
Water phase comes in from this line.
И после смешивания всех компонентов подается продукт на коллоидную мельницу.
After mixing, the product goes into the colloid mill for final homogenation.
Мы имеем выход уже готовой продукции.
And this is the product output line here.
Еще также по поводу разжижителя. Здесь есть кран подачи разжижителя.
Regarding thinner, here we have a valve for a thinner supply.
Он работает по тому же принципу и также осуществляет подачу перед входом в битумный насос, как и в предыдущей установке.
It's based on the same principle as the smaller machine. It supplies this thinner into the bitumen pump, right before the bitumen pump, actually.
В данной части установки я хочу вам предоставить водную линию для приготовления водной фазы.
And this, and this section here is the water phase section for the production of this preparation of water phase for the production.
Здесь я хочу отметить маленькую разницу, в том, что мы имеем два насоса.
And here we have somewhat of a different design from the previous smaller machine. We have two pumps here instead of one.
Насос обеспечивает подачу и циркуляцию воды с внешней емкости.
This pump here facilitates supply and circulation of water from an external tank.
А второй насос, так называемый купажный насос,
And the second pump is what we call a blend pump.
делает купаж, то есть смешивает компоненты для приготовления эмульсии с водой и уже подает концентрат вместе с этим насосом в битумную линию.
So the second pump mixes the ingredients and water and supplies this concentrated blend along this line here to production.
В автоматическом режиме они работают вместе, то есть
In automatic mode, these two pumps operate together. So this is what it means.
концентрат подается этим насосом и дополнительно подается еще делается подача воды вместе, чтобы для разбавления концентрата и подаем все в битумную эмульсию.
The first pump supplies both the concentrate and also draws in fresh water to dilute that concentrate to the required concentration for the production, and it supplies the blend into the production.
Конечно, что наши установки оборудованы рядом датчиков, как первая установка, так и это датчики температуры и давления.
Obviously, both systems are equipped with process parameter sensors. That would be the pressure and temperature sensors here.
Это позволяет нам контролировать процесс и избежать любых аварийных ситуаций посредством контроля температуры и давления во время процесса.
And these sensors allow us to make the process safe and efficient, precise. We can avoid any potential hazardous situations with overpressure or overheating.
Очень важно следить за температурой эмульсии, потому что она не должна превышать температуру кипения воды.
It's extremely important to watch the temperature of the emulsion because the temperature of the emulsion must not exceed water boiling point.
И также, соответственно, давление в системе необходимо просматривать. Почему? Потому что работа машин происходит под высоким давлением, это порядка 14 атмосфер.
And also the pressure is very important to keep a track of because machines operate on an elevated pressure, something like 14 bar or so.
В случае возникновения каких-либо аварийных ситуаций, конечно, имеется emergency stop, мы называем аварийный стоп.
Of course, there is the emergency stop button for any situation that may require such emergency stop.
Но посредством контроля оператором показателей машины работают отлично и ничего не должно случиться.
It's rarely used, if ever, because the sensors and the output of the sensor measurements allow the operator to control and manage the process and prevent any such sort of emergency or breakdown.
На данный момент это практически все по основным компонентам. Если у вас есть вопросы, вы можете их задать в чате и непосредственно менеджеру.
So again, yeah, this is just about everything there is to it for the machines. And if you have any questions, there is a team here in the chat standing by to answer those questions. Thank you for your attention.
Спасибо за внимание.
Thank you. All right, this concludes the presentation really for this time, and I'd like to thank you all for being here. It was a pleasure to present this information to you today. Again, I'd like to remind you, if you require a certificate of participation, please write to us. And you can also receive a 5% discount on these two machines that we showed you in the end. If you want that, also write us in the chat window or by email. Okay, been happy to see you here. Stay tuned. There will be more presentations in the future and more webinars on different topics. So I hope to see you back here soon. Goodbye.